Hello, my name is An. Today I'm going to make an experiment to determine the coefficient of restitution, which also determines the bounciness of the ball. And today I'm going to make two trials. The first one, I'm going to set the original position at 49 feet, and the second one, I'm going to set it at 59 feet. And so let's get started. And this is my ruler. I'm going to set it at 49 feet. There. I hope you can see that. Okay, so I'm going to drop the ball at this height. And let's see the height, the final position when it rebounds is how much. Ready? 1, 2, 3. I can see very clearly that it reached 16. 16 is right here. 16 feet. I mean 16 inches. And the original position is 49 inches. And the second trial, I'm gonna set it at 59 inch for the original position. That's 59 there. And I'm gonna drop the ball at this height. And I'm gonna watch it carefully. 1, 2, 3. Okay. I can see that it reached 20 inch when it rebounds. So that's pretty much for the experiment, and I'm going to show you how to apply this value into calculation, which I'm going to do next. So in order to determine the coefficient of restitution, we need to know the equation, which is this one right here. The first one is the equation of coefficient of restitution, stated that the relative speed after collision over the relative speed before collision, and also the equation for the principles of conservation of energy, stated that the sum of kinetic energy and potential energy before the balls hit the ground equal to the sum of energy after the collision. And this is the equation for kinetic energy, which is 1/2 times mass times velocity squared, plus the potential energy, which is mass times gravity times height. And the same thing with the energy after the collision. So why are those important? Because we're going to apply them into this in order to find out the value of E. And in this equation, I already factored out the mass to make it more convenient. So after I factor out the mass, which is right here, right there, and right there, right there, the mass, I factor them out, and I'm going to get this equation. This equation, 1/2 velocity squared plus gravity times height. And you can see that there's no mass there because they're a common factor. And so now I'm going to plug in the value. You can see that the original position that I used was 59 inches, which is equivalent to 1.50 meters. And so right here I use the height 0 because wait, hang on. Right here I use velocity is 0, and the height here is 0. The final height or final position is 0 because when it hits the ground. So there, I just plug into this equation, and then I cancel this out because this is the position when I'm holding the ball, and this is position when it hits the ground, which is the distance 0. And so after I plugged in everything, I get the velocity is 5.42 meters per second. And this is after the collision. I just use the same equation, but now I put this one equal to 0, because at this step it is from here, from the ground moving up, and right here is when it reaches the maximum height. When it reaches maximum height, it stops moving. So right here is 0, and right here is 0 is a kinetic energy because the velocity is 0, and right here the potential energy is 0 because when it's from the ground, when the height is 0. And so you just plug in everything and you solve for the velocity when it's started moving up. It's 3.157 meters per second. Afterward, I just plug in the value into the equation of coefficient of restitution right there, and this is the relative speed after collision over the relative speed before the collision, and I got that answer. And I tried the second trial and third trial, and they should have the same value for coefficient of restitution because the ball is made up of the same material, and we use the same ground. We're not changing the position or the location that I do the experiment. And that's pretty much for my experiments. Thank you for watching.